Hi, my name is Michael Hahn, and I'm one of the Vision Application Engineers here at R.R. Flutie Company. I've been here for over 24 years, and I'm one of 6 vision engineers at R.R. Flutie Company, and we've been solving machine vision applications for over 21 years. And in that 21 years time frame, we have solved over 15,000 vision applications for manufacturing. We kind of have a saying here at R.R. Flutie Company that we've been involved in vision applications from slaughterhouses to aerospace and all things in between. And in that 21 years time and 15,000 plus applications, we've kind of got 6 guidelines to having a successful machine vision application. 6 rules, if you will. And that's what I'm going to be speaking to you here about today. And in those 6 rules, we start with the very first one, and that is good data in is good data out. Why is that important? In machine vision, coming up with a scope of work on what is the defects that we're looking for is usually the easy part. Collaborating with the customer, we can kind of come up with the defects on what we're looking for. The harder part in machine vision is not looking or spotting the bad defects. It's really understanding what we call the bell curve of good. Let's say you have an automotive application, an injection molding machine process. One good part to the next good part, from one day to the next day, from one week to the next week, each part is not exactly the same. The plastic may be a little bit glossier, may have a little bit more matted look to it. The metal inserts may have a different sheen to it or a different cut to it. And so good parts may fall somewhere within the bell curve of good. They're not exactly the same. And so it's our job to make sure that the solution has enough bandwidth that the good parts fall within this space here and the bad parts, of course, fall without or outside the band or the bell curve of good here. And so really what we recommend customers to do is have a master set of good images and a master set of bad images to run through the emulator to make sure that we can tell the difference between good and bad. So rule number 1, good data in is good data out. Rule number 2 is always start with a golden image. Now, why is that important? Simply, there's 2 reasons for this rule. It's you always want to train in a good part when you're programming machine vision application. Again, we go back to the bell curve of good here. If I have a good image of an application, I want to start by all my tools that I have. I want to actually start on a good image so that I actually train in what good looks like, and then the bad or defects fall outside of the parameters that I've set forth. That's the first reason for rule number 2. The second reason has to do more with human nature. Just the decades of experience that we've seen with people is that if they can continually go back to the same good image when applying tools and checking their work and making sure that the application is sound, that it's more comfortable for them to work in that space. So again, rule number 2, always start with a golden image.